Okay, so let's start today class. Today we are going to discuss about the three-phase half-wave uncontrolled rectifier. Okay. In the previous class, we have already discussed single-phase semi-controlled rectifier for the RL loop. So how we can simulate a circuit for three-phase? Okay. How we can simulate a circuit for three-phase of resistive load? So how many switching device required for half-wave? That means here three switching device required here and three single phase AC source in place of single AC source required for the single phase circuit simulation. Okay. So first of all, we just try to share the screen and open the MATLAB, the previous one. So just wait few minutes to open the MATLAB and then we will simulate a circuit of three phase half wave uncontrolled rectifier. That means we require a power electronic switches uncontrolled device, that means diode. Okay. So how many diodes we required here? Three diodes. Okay. So all the components tagged from the Simulink library to the new workspace. So just wait few minutes. Continue. It takes some time for opening the MATLAB. So just wait.
ये जो अपन कॉलेज पे गया हो या अब पूछे थे कोई दिक्कत तो नहीं है हम ये इंस्टॉल करने की कोशिश कर रहे थे लेकिन जब लाइसेंस का शो करने के बाद आ रहा तो तब ऑन नहीं हो रहा था
Okay. So this is the interface of the MATLAB. Now we just open new workspace, that means create here from this place. Just click here and one Simulink model create, that means name with and title. That workspace we just designed it. circuit for the single phase half wave uncontrolled rectifier. So it takes some time. So creating a new space here. It's sometimes for open the MATLAB. So just take few minutes. Yeah, so this is new workspace where we can design the single phase half wave uncontrolled rectifier. That means we require three power electronic switches which is uncontrolled. That means we select three diodes and one resistive load. So first of all, just save this model. Save in this folder of the desktop. Just, in simulation lab. Okay. So now we already model some models. So name this model as model number 11. Model number 11. Okay. So this untitled workspace save as the name of model number 11. Okay. Now we just open the Simulink library and drag the all required component. So just here Simulink library. Click on the Simulink library and choose all the component required for design the circuit. Okay. So just again go to the first of all SimScap. So here is the SimScap, and in SimScap again go to the Sim power system. Okay. Sim power system, and in Sim power system you may find out various type of power electronics device available here. So go for the power electronics, which is that means diode. Okay. So just click here on and add model number 1, model number 11. Okay. In model number 11, next you go to the you drag the diode in workspace. Yeah. Next. Source, electrical source. So you may find 3-phase source. Okay. So you may find either 3-phase source or maybe 3 single unit, single phase source. Whatever you maybe want, you just drag on the model number 11. Okay. So both are available here, that means single phase as well as the 3-phase. So you may choose as 3-phase model number 7. Okay. Next, what we require, a scope. Okay. So again go to the sync. So here various type of sync available. So choose according to your requirement. So again just click on the scope and add model number 11. And next for the measurement of input and output voltage. So you may be right here voltmeter. So go to the measurement part. It is here and just drag to the workspace. Model number 11. Okay. And again go to the power guide block for the operation of this power system. So just write here power guide. Press enter. So power guide is available here. Now just drag to the model number 11. And resistive load required. So again go to the element. Here various type of electrical element available. So just choose the series RLC branch. So again go to the series RLC and add to the model number 11. Okay. So I think we all the necessary components drag into the model number 11. Now just simulate the circuit for the single phase, half wave and control rectifier. Okay. So just go to the model number 11 and just click on this for full screen and just try to track all the event here. That means continuous. Face problem. So continuous power guide, just voltmeter track to this point and scope to this point. And this is a 3-phase source. So we require 3 diodes. No? So just create from this diode number 1, diode number 2, diode number 3. Okay. Maybe unit this one. Now you just rearrange this connection. Okay. So if you put on this 3-phase AC voltage source, So here is given to you positive sequence amplitude VRMS phase to phase and phase in degree and frequency. Okay. So if you change their amplitude value peak, that means VRMS phase to phase. So what is the line voltage? That means RMS voltage is around 440 volt. Na? So if you multiply by root 2, then you will get the maximum amplitude. So it may be right here. (440) into root 2, that means 1.42. Okay. And frequency is your 50 hertz. So just type here 50. Okay. Phase degree is your 0. So just apply and click here. Okay. So just rotate this AC voltage source controlled by R. So here phase A, phase B, phase C. Okay. So now the diode just connected this way. Phase A, phase B, and phase C. So this one is your phase C. Okay. Now we will connect this one from this point. Just wait. So just this, put here 0 and apply and OK. Okay. So similarly, this second diode, also put here forward voltage drop is taken as almost primary, so 0 voltage. If you apply and OK. Okay. Your diode number 2, this one diode number 3, in the same place. 0 volt. Apply and OK. Either you maybe take 3 single phase source also here. Okay. Now just connect from this point to diode number 1 and this point diode number 2 and this point to diode number 3. Okay. Now you maybe just simplify the circuit in this way. Okay. So this is your anode of the diode and this one is your cathode of the diode. So let me just connect the positive terminal of the supply with the anode of the diode, and all these 3 points will be connected here. This one and maybe this one. Okay. Now you just connect load. So this RLC branch maybe you convert it into purely resistive circuit. If you click on that block and choose the types of load, so that will be required here for pure resistive load. Okay, so select on the pure resistance. You maybe put their resistance value, or if you take the default value taken as the 1 ohm. Okay, or either maybe you put any specific value for the resistance. Let me suppose that if I put here 10 ohm. Okay, so 10 ohms apply and okay, then resistance value is your 10 ohm. So this load is your resistive load. So if you rotate this one, now just connect from this point to this point. Yeah. And now connect from this negative polarity of the load to the negative polarity of the supply. Just connected here. Now maybe connect one voltmeter for the output voltage waveform. That means this voltmeter you may be connected across the output of the resistance or resisting load. Just connect from this point and this point. Okay. So if you want to analyze the output current waveform also, then you just require one emitter that connected in series with the load. Okay. So that emitter you may be derived from the Simulink library. So again go to the Simulink library and just go to the measurement part and just add one emitter in this model. Okay. So this emitter you may be connected in series with the load. So just put here from this point to this point and from this point to this point. Okay. Now if you want to measure all the voltmeter, all the supply voltage of the line to line or phase, then you require 3 voltage here in the supply voltage waveform. So you maybe connect 3 voltmeter. So we create voltmeter here, and again voltmeter here. Okay. If this voltmeter connected across the phase A and B, so it shows the line voltage between the A and B. Okay. So maybe just connect it. 1 voltmeter here. That means between the A and B. Okay. So just connect at this point. This point. It's not exactly connected, so just connect in proper manner. Now, so this voltmeter connected across the line A and B. So voltmeters voltage variation shown by this voltmeter is a voltage line between the A and B. Okay. And now, if you want to measure the phase voltage, either of the phase voltage, so one voltmeter connected between the any phase of A, B, and C, and this voltmeter, suppose that connected between phase voltage A. So connected to this point and this point, that means negative. So this one is indicated phase voltage, and this one indicate line voltage. Okay. Similarly, you may be measure all the 3 line voltage, that means line voltage of AB, BC, and AC. Okay. Suppose 1 voltmeter again connected to B and C. Okay. So this voltmeter is connected to this point B and C. Okay. Now this voltmeter again connected between the A and C. So this voltmeter is now A and C. Okay. So again go to this point. Either So C terminal is also available here. So just directly connected from this point to this point. Now, how many axes you have to require? That means 4 supply voltage. That means 3 line voltage and 1 phase voltage, and 1 output voltage and 1 emitter. Okay. So I think required 5 number of axes. So just click on the scope. Yeah. And if you go to setting and just put the number of axes here, that means 5. Okay. So 5 axes create here. Now apply and okay. So 5 number of axes create here. 1, 2, 3, 4, 5. Okay. Now just again go to the okay. So 1, 2, 3, 4, 5. So line voltage of supply between A and B is just connected. Suppose that at first axis, and line between this one is your B and C. Okay. So just connected here at axis number 2. Okay. And this one just connected at axis number 3. And this phase voltage is just connected at fourth, and this emitter output voltage is just connected here. One more axis required for this emitter connection. So you just increase the number of axes here. Just again go to the setting and click 6. Apply and okay. Okay. So 6 number 1, 2, 3, 4, 5, and this emitter output is connected to the 6 number of axes. Now just click on the continuous, that means power guy block. Here you can go to the configuration parameters. Okay. So click on the configuration parameters, just select display type. Okay. Sample time is battery power current taking as 50 microsecond. So 50 into 10 to the power minus 6. So apply. Okay. So just close this one. Now I think we just complete our simulation of the circuit for the single phase half wave AC board. Okay. Okay, fine. So just set here sampling time 0.3. Now just run this model Compiling is complete. Now you can check the waveform of the various components. Okay. Again, go to the auto screen. Yeah. So this is the voltage of the AB, voltage across the BC, and voltage across the AC, and voltage phase voltage. That means any phase voltage is VAN. Okay, VAN, or maybe change their terminal VBN, VCN, one, and this is your output voltage waveform for the single phase half wave uncontrolled rectifier. Okay. And this is last one is a output current waveform. Since it follows the same as the voltage waveform, because the our load is resistive load. You know, our load is resistive load. So in this way you can simulate the circuit for the three phase. Okay. So these are the various waveform. That means line voltage of P line AB, P line BC, P line AC. Okay. And their output voltage and output current waveform both are similar because the load is resistive purely. Okay. So whatever the waveform of the voltage that follow the current waveform. Okay, also current waveform. So you may be consider here three single phase AC source in place of three phase AC source. Okay. So you may practice for three single phase AC source. That means how we can just select for that if we want to simulate with three single phase AC source. Okay. So just eliminate all this portion. That means whatever you will be required here. That means again remove this one. This voltmeter. In this voltmeter. So just use the single phase AC source. Okay. So just remove all this component here. That means three phase source. So there voltmeter connection and emitter. Now you want to just replace this three phase AC source by three unit of single phase. Okay. 3 unit of single phase. So just remove this three phase. And again go to the Simulink library and select three unit of single phase AC source. So go to the Simulink library and go to the electrical source. Okay. So we maybe choose a single AC voltage source. So try to the model number 11. Okay. So now this AC volt, so that create here 3 units required. That means unit number 1, unit number 2, unit number 3. Now this AC voltage source is just connected with the phase A. Phase A. connected here. Okay. Again, this voltage source is connected to this. So just move directly towards the cell. Yeah. Now this is the voltage source. Place here and connected to this point. Okay. Move from this point to this point. Okay. Now just connect all the negative terminal of this AC voltage source from this point to this point and this point to this point. Okay. So now it is connected in proper manner. Now we just connect this polarity to negative of this polarity. So we just connect from this point to this point. Okay. This voltmeter, output voltmeter, we will connect it. Now all these three phase are displaced from in a space 120 degree to each other. So just put their value in degree. So this phase A, okay. So just click on this one. So if you do not put any particular value, then taking as a default value at 100 volt maximum voltage. Okay. And phase degree is 0. And just put here frequency rating, that means 50 hertz. Okay. And just apply and okay. Next, just click on the phase B. Okay. So what is the amplitude? Amplitude is same. By default, we are taking as 100 volt. And what is the phase degree for the phase B? So 120 degree, na? So just 120 degree. 120 degree. And frequency is just same as the previous one, that is 50 hertz. So just apply and okay. Next, just click on the phase C. Okay. So by default value is amplitude is 100 volt and phase, what is the phase delay? 240 degree. Is it not? So 240 degree and frequency is again same as 50 hertz. Okay. So apply and okay. So you maybe connect 3 voltmeter, 1 voltmeter across each A, B, C. This terminal may be named as phase A, phase B, phase C. Okay. This one is for C. So you may mark here phase A, okay, phase A, and this one is your phase B. So just mark here phase B, and this one is your phase C. Okay. Now we want to just verify this space phase angle between the phase A, B, and C. And we know that the 120 degree phase displaced from each other. Okay. So 3 voltmeter you may connect for that one. So just place here 3 voltmeter. That is voltmeter number 1. Voltmeter number 2. So you maybe connect this voltmeter 1 across the phase A. Okay. So this voltmeter just connected here in this manner. So just control R. So you are able to rotate this block. So connected from this point to this point, and this point to this point. Okay. So the output of this block you just connected here. We will connect voltmeter across the phase B and phase C. So these voltmeters suppose are connected across voltmeter phase B and phase C respectively. Okay. This one, and this voltmeter is connected across the phase C. Okay. So here is phase C. That means we will connect at this point to this point. Now you just connect this voltmeter. That means at this point, this voltmeter output. That means B and C. So this one will connect at this point, and this voltmeter is connected at this point. Now, so how many number of axes required here? 4. So just we stop here and just click on the scope so you maybe see their variation. Okay. So just